Okay, we've got 3 machines, each one makes biscuits. Okay, we know the probabilities of that happening. Each machine is being used for a particular biscuit, and then we know the proportion that are broken. In other words, more probabilities, and it's kind enough to tell us to draw a tree diagram. So there's going to be some probability for any biscuit that is on each of the 3 machines. So the first phase is going to be JKL, and then for each biscuit it's either going to be broken, or each machine the biscuit's either going to be broken or not. So each of those splits into 2, and you can use these probabilities to label up the branches. This will be adding up to 1 with the other 2, and then for the second stage we know the percentage of broken, so we can fill in the not broken, and you can work out 6 answers by multiplication along the branches. And then for the first, well, and by putting all of the probabilities and all of the labels on, so these need to be labeled B for broken and B dashed for not broken each time. And then find the probability the biscuit is made by machine J is not broken, so that's just one particular route through the tree, that one there. And then find the probability the biscuit is broken. Well, there are 3 ways that can happen: here, here, and here, so those 3 get added together. And then, given the biscuit is broken, find the probability it was not made by machine K. So that's by far the most challenging thing. So we've got to say, we've got to first of all remember that the probability of A given B equals, well, it's a division, and on the bottom we've got the probability of, it's the one after the line, so it's B. So we want the probability of A and B over the probability of B. So what B is the thing we're given, so that's the probability it's broken. Well, I've just worked out the probability it's broken, so the probability on the bottom of that fraction is going to be my answer to part C. And then on the top, it's got to be the probability, that should say A and B. Oh, sorry about that. Okay, that should say A and B. That's the probability that it is not broken and it was not made by machine K. In other words, that it was made by J or L. So if it's, and it is broken. So B is the fact that it's broken. So that means I have to add up the probability of it being broken from J and, added to the probability of it being broken for L, because that's the overall probability that it was broken, but it was not made by machine K. So it's the total of those 2 values that goes on the top of the fraction, and that's how I get my conditional probability. So when we look at the mark scheme, here we go. This is the tree diagram as discussed with all the probabilities on. It's quite nice. What they've done here is they've worked out all the possible answers before doing anything else, which is not a bad tactic, but the marks are just for the first, for the actual diagram itself with all its labels. Okay, and then we've got the methods and the answers for the first 2 parts, and then we've got, as discussed, this is the way that we discussed doing it here. This is the way of doing it by subtraction. Okay, 0.0035 is the probability that it was broken. This is broken from J, this is broken from L. Okay, I could do the overall probability that it was broken minus the probability it was broken from K, but this is the way I'd do it, and this is the answer you should have got, so I hope that helps.